Algebraically determine if each of the following functions is even, odd, or neither, and verify your answers graphically. So because this doesn't tell me that I can't use a calculator, when I graph these, I'm going to go ahead and just throw them into a graphing calculator to see what they look like. So first, though, I have to find the three equations that help me check for even, odd, or neither. So the first equation is given to me, f of x. The second equation is when I plug in negative x wherever I see x. And I'll simplify this in just a second. And then the third one will be when I multiply the entire thing by -1. And so I'm going to simplify the first one here. If I do negative x, so this becomes 3 times negative x times negative x times negative x plus, again, 5 times negative x minus 1. So this ends up becoming a negative times a, sorry, I guess a 3 is positive. So positive times a negative times a negative times a negative ends up becoming a negative 3x cubed. This also ends up becoming a negative, and then we have minus 1 there at the end. So now we have f of negative x. That's the second equation we're going to need. And then the third one, I'm just going to distribute this negative to get negative f of x is equal to negative 3x squared minus 5x plus 1. Now, if these first two are equal to each other, that's when we say it's even. Obviously, they're not because they have some of them that have flipped signs, so not even. Then I'm going to compare these two here to see if we get an odd function, and because we can kind of see that this final sign here is not the same, then we say that it's not odd, and therefore it is neither. When I put it into a graphing calculator, I'll see it's kind of this, it's a parabola, and it's shifted in a way that looks kind of like this. And so obviously not even because it doesn't flip over the y-axis. And then if you're rotated 180 degrees, it would be pointing in the wrong direction. So neither makes sense. Second one here, we got, we'll do in blue here, our original equation, which is important, then g of negative x and then negative g of x. And so to simplify this one here, when I have negative x squared, that would be negative x times a negative x, which is just going to be a positive. Same with the next one, it's negative x and 4 times. And since I have this even number of negatives that I'm multiplying, it ends up becoming positive. So we get positive 3 over x squared, and then plus, that also becomes even, and minus 1, g of negative x. Now, I'm going to keep going here. I don't necessarily have to, because what I see here is that my original equation and this one here are even, or sorry, are equal. Therefore, it tells me it's even. I'm just going to really quickly go through and find the other one just to show the algebra here, but it ends up becoming negative 3 over x squared minus 5x to the power 4 plus 1. And so, again, whenever we're trying to check even or odd, it can't necessarily be both. And so when we do this, we're going to have one or the other, and if it's a function at least. And we are going to say this is not odd because those are not the same. And so this second one here is even. The graph also makes it look even because it looks, again, it's an interesting looking graph, but it's like really skinny and really tall W shape. And it is more symmetrical than what I just did, but hopefully you can bear with me in my drawings that it looks like when I see it, it reflects over the y-axis.